Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Today we are going to be looking at how to parse XML and HTML using the third-party library Beautiful Soup. This is Meetup 133. Where every Tuesday we have a Python session. On the first Tuesday of the month we have a session for absolute beginners, and every other Tuesday is something a little bit more advanced. Occasionally we just look at straight Python things, and that's what I will normally do. And then on other Tuesdays we have Arun showing us some machine learning code. I encourage you to ask questions during the session. This is a live session, so if you're watching it live, then please ask questions on the YouTube chat and also on the Slack channel. So there's details of the Slack channel down below in the comments below this video. You'll also find in the comments below, you'll find a link to a Collab notebook. So we'll be using Collab for tonight's session, which means you don't have to have Python installed on your computer. It will be using Python 3.7 provided by Google, so you will need a Google account to be able to follow along. Okay, so here looking at the meetup, I've got the link to the notebook here, and it's also below the video in the comments. Okay, so if you click on that link, it'll bring up the notebook, and it brings up the original version that I created, but you won't be able to make changes and save to my version. So what I recommend everyone do is click on Copy to Drive, and that'll create a local copy for you to be able to make changes. And so I'm going to have a local copy that I can make changes to. And I'm even going to share this one so that you can have a look at any changes that I might have typed in. So anyone with this link will be able to see it. Let's copy this link, and I'll paste that into the YouTube chat, and I'll also paste it into the Slack channel. So here's our Slack channel. It's Beginners Python, and it's in Learning to Code is where you can ask questions, and you can also ask questions, of course, on the YouTube chat. All right, now it's not the first week of the month, so we're going to be looking at a bit more advanced stuff tonight. But even if you are an absolute beginner, you're still encouraged to ask absolute beginner type questions, because everyone will benefit from that. And really, this is just I'm just introducing material to encourage you to ask questions. All right, so a quick look at Google Colab. You've probably seen it before. If not, definitely ask a question. But it's just a bunch of cells here. They're text cells and code cells, and if you see here I hover, I can add in new code cells or new text cells. So here I've selected in this code cell. The first thing I'm going to do is click on connect. You don't have to do that, it'll do it automatically when you try to run some code, but it'll just save a bit of time. Now normally what you type into these code cells is Python code. It's interactive Python, but you can also get access to the computer that's running the Python by prefixing anything you type with an exclamation mark. So remember, prefixing with a hash sign, that's for any Python comments you want to put in. Prefixing with the exclamation mark will run a command. So for example, I'm just going to add in another code cell here. And if I want to get a directory listing, I can type ls, and it's a Unix computer that's behind it, and then I press Shift Enter to run this cell, and it tells me that there's only one folder in this directory that I'm in, and it's called sample data. Okay, and if you look over here on the left, you'll see there's another way of looking at your folder you're currently in, and there's the folder called sample data, and you'll see that there's a few files in there of sample data. So even I could have done ls, let's see, ls sample data, and it would give me the list of files that are in that folder. Okay, so in Python there's a command pip or pip3, which is what you use to install third-party libraries. But because we're using Google Colab, it comes with a bunch of third-party libraries pre-installed, pretty similar to the list that you'd get if you were using Anaconda. So let's have a look. Pip list will tell me all those libraries that are pre-installed, and you can see there's quite a few of them and the versions that are there. So if you had a straight Python install and you ran pip list, then you'd get hardly anything here. So if you're running a Linux computer or a Mac computer, you just type pip list or pip3 space list, and without the exclamation mark to get this same sort of list. Okay, Beautiful Soup is already installed, version 4.6.3, so that's what we'll be using tonight. And also there's one called LXML, JKL, that one, and that one's also installed. So we don't have to install anything at this stage, so let's move on. Now if you want to use any libraries, either standard libraries or third-party libraries, you use the import statement. So you can import an entire library, or you can just import one function from the library. So there's a standard library called url_lib.request, and in there's a function that we're going to use tonight called url_open, and that's for getting web pages and opening them, so we get the data from the web page or the XML page. If you want more information on that, you can go to the documentation at this address. The docs actually recommend using a different library, and that's a third-party one called request. So if you're doing anything a bit more complicated than just opening a URL, then you probably use this request one, and there's the documentation for that. But rather than have to install a third-party library when we don't even need it, because we can just use a standard library, I thought I'd use a standard library tonight. Okay, so let's run this cell. I can click on the play symbol here, or you can see I could press Control Enter. I'll just close this, click there. And that's now being run. And you can just put the number 4 there, say it was the 4th cell that I've run. Okay. So here I'm going to import just this class Beautiful Soup from BS4. So this is a third-party library, but it has been installed, and it's also got some quite good documentation over here. So I'll open up that documentation. So I'll hold the Control key and click on the link, and this gives us the Beautiful Soup documentation. And it's quite good. It's really easy to follow through, although I find I have to read quite a long way down before it gets to where it does stuff that I actually need to be able to do. So hopefully what we'll do tonight is get quickly into things that are useful, but the Beautiful Soup documentation is definitely more comprehensive and gives you a bigger range of things that you can use it for. Alright, so we're going to, first thing is we're going to look at the Reserve Bank's exchange rates. and these are published on an RSS feed, which produces XML files. So let's have a look at that RSS feed, and this will give you an idea of what the data looks like. So I just clicked on that link, HTTPS link for the Reserve Bank of Australia, and it gives us this XML, and this XML is standard XML for an RSS feed. So if you've got an RSS reader, you could read this in and it would understand most of the terms here. So if you're familiar with HTML, you can see that XML looks pretty similar. It's got angle brackets around tags, then it's got tag names and some attributes, and then some text in between tags. One thing that's a little bit unusual is some of the tags have got these prefixes with a colon, and also some of the attributes have got prefixes with a colon. And what they are, they're part of the namespace. So the standard XML is defined here by a schema, and the schema is at this place here, but the schema doesn't include everything that's in this file. So anything else that's not included in the schema, it has to, those tags have to be defined somewhere else. And because there's so many different people around the world defining tags, they came up with this way of making sure that everyone came up with unique tags or unique attributes for existing tags, and it's called using an XML namespace. So to define a namespace, you say I've got an XML namespace, and my namespace is, and it's usually going to be in the form of a URL, and usually that URL will actually give you some interesting information about it, how it can be used. But that URL obviously is going to be unique. This one, CB Wiki, is for the central banks of the world, and so that's the namespace. However, you don't want to be typing that on every single tag that uses it, so we put in a little alias. You can make that up whatever you like. Here we've used, they've used CB, which makes sense, but they could have used any initials there, and if you had another namespace that was often using CB, you could just call this one something different, and as long as you used the right prefix in the right place, everything will work fine. Alright, so we're going to use our URL open function to open that URL and store the results into a page. So the page is just a variable. We could call it anything we wanted. And we're going to use the with format. So with is what Python does to make sure that any resources that you open get closed. So that's a really safe way. If ever you can use with, then use it. Because it means that you don't have to remember, have I closed that resource? And if you leave resources open, it can waste memory. It can you can reach limits on how many resources can be open at any one time, especially if you're not closing them and you've got all these hundreds of resources open that you're no longer using. So with will automatically close anything that's been opened when it reaches the end of the code block. Now a code block, as you know, is all the indented code underneath the with. So the with is there anything that's indented 4 spaces or even indented further. It can be run with the resource open. Once you get at the end of that, which was the end of this cell, then it will automatically close that resource. Alright, so I'll run that cell. It's going to take a little bit of time to run because it's got to go off, fetch that web page and store the results into page, and then it's going to pass that into beautiful soup and create a soup, and we're telling it that it's XML. So remember to tell it it's XML, and because it's XML, it'll use this LXML library that was installed previously. If you're using HTML, then under features here you can put in, you can choose different parsers. You can call HTML.parser. LXML will also parse HTML, so it's a little bit confusing, but if you put in LXML for the feature, it will assume that it's HTML. And you can also use HTML5lib. Alright, now if you read through the documentation, you'll see how to access stuff in the soup. And the soup, you can use either this attribute notation, or you can use index notation with square brackets. So let's use soup.item, and we'll see what that gives us. It's going to give us the first item in the soup, and we've run prettify on that so that it formats it nicely for us. And there you can see that's the first item, and it's got a description, a date, a language. So if you remember our code here, if we look down here, we'll see that's items. That's not what we want. We want item, which is this one here, item, and it's got a title, link, description, date, language, audience. So this is the information that we've now got out on each item, and you can see that each item is going to be a different exchange rate. So this first one is going to be the US dollar exchange rate, 0.7121. The next one is going to be the Chinese exchange rate, 4.5292, etc. Okay, task 1. So is a good chance to get your hands dirty. Try playing around. I've even left an empty cell there for you. So you want to find the first tag that's called CB : exchange rate. So remember the last one we did was item. So if I do soup is what I got out of beautiful soup, and then I can just call exchange rate, and that will find the first one and give me all the everything that's enclosed in those tags. Now you see when I'm using this attribute notation, so dot is an attribute notation, I don't use these namespaces. Now the other way is you can use find, and that will find the same stuff. And if you're using find, then you can also use put in the namespace. It's the same. All right, let's have a look at the solution. It did the same. You use the find way of doing it. Yes, so I can run that, and we get the same information. Now, because I haven't used prettify on this, it's just listed it all vertically aligned, but if I did prettify, it would do some indentation to make it easier what the structure is of this tag. Okay, so sometimes we want to find the text that's between the tags. So for example, like 0.7121. Yep, and Leo's ahead of us. He's using .text as well to find all the text that's inside exchange rate. So let's have a look at what we get when we do that. So I'm going to create a new code cell. And so that's printed all the text without any of the tags. And we'll get into that more later. Okay, text extracts the text from tag and all descendants. Now you've also got .string. We'll extract the text from just the tag only, and only if it is unambiguous. So that means no subtags, or exactly one direct subtag, and that subtag has a string, then it will also return that value. Now you can also do .strings, and that'll give you a list of all the .strings from all the descendants. So let's see. In fact, there we go. Superexchange.text prints that. All right, display the string value for a tag which has a string. So let's have a look back here. So have a go at these yourself. You could even pause the video if you want and then play it on a bit fast forward so you can catch up. Let's have a look. Let's find unit, and so we want AUD. So soup, we're going to look at the unit tag, and then we're going to find the string value of the unit tag, and there it is, AUD. Alright, so let's have a look at the solution that's been provided, a bit more comprehensive. This is going to, for that item, it's going to go through all the descendants in an item. So a descendant is a subtag. It's going to look at the name of that tag, and if it's not none, and the string is not none, then it's going to print the tag's parent's name, the tag's name, and the string of the tag. So let's see what that gives us. So this is the parent, item, 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 item. An item has a title, a link, a description, and these are all the string values that we could see for all those tags. Then there's a country, and the country has a parent called statistics. So we didn't see statistics in this list because for statistics the tag.string will be none. But statistics has some subtags, country and institution abbreviation, and they both have strings, so they are showing. Similarly, observation has value, unit and decimals. Exchange rate has base currency, target currency, rate type. Observation period has frequency and period. So you can get quite a bit of information out of this just by looping through the descendants here. Okay, so soup.target currency.text extracts the text from the first target currency, and we've got target currency there, so that's string for target currency, and this is text for target currency. So they're both the same thing because there's no descendants there of target currency. And as we expected, target currency.string also works. Alright, now we've seen how soup.find finds the first tag, as I say, just the way that soup. And some tag name does. But there's also a find all, and that'll give you a list of all the tags that have that tag name. So I'm going to store that in a variable called items, and we're going to find all the tags that have the name item. I guess that's a bit confusing because there is actually already a tag called items, but that's not what we're looking at. We're looking at all of the tags called item. And we'll see how many there are. There's 20 of them. So that'll be the 20 exchange rates that are in that RSS feed. Okay, task 3. Go through all the exchange rates by currency code and look up the rate for Japanese yen. Okay, so let's go through each of the items in items. So each one of these items is like a little soup. So remember, we have our first soup was the whole document object model. Now we've now got a list of these tags, and they're just a sub part of the whole HTML. So each one of those will have tags inside it, and we can just treat it just like we were doing with soup. Go through all the exchange rates by currency code. Okay, so if item dot and we can just put in a tag name here. Target currency is the name of the tag that stores the currency code, and we want to look at the string of that. So if that equals Japanese yen, then we'll find out what the exchange rate is, which is just stored in a tag called value, and we'll look at the string of that. Okay, and we want to print that. Once we've found it, we don't need to keep looping, so we can just break. Okay, so Leo's asking, is there a way to go directly to Japanese yen without having to loop through? And there is, but we'll be looking at them. They're a little bit more complicated, so we'll look at them later. Okay, so there it is. The exchange rate is 82.18 Japanese yen for $1 Australian dollar. Now this is the solution is slightly different. I just went through the items and looked at the subtags of item, but we could do it on soup, and we can use find all. So find all tags exchange rate and put the results of the target currency.txt and value.txt into a dictionary. So we've created a new dictionary here, rates from soup as an empty dictionary, and each one will have a key, which will be the currency code, and a value, which is the exchange rate. And then we'll print, I'll just use pretty print to print the dictionary because it looks a bit neater, and then we can look up the dictionary for Japanese yen. So that's one way of going straight to Japanese yen from now on, but I've had to create that dictionary first. So there's my dictionary I've created, Japanese yen 82.18, and then this last is the print statement. 1 Australian dollar equals 82.18 Japanese yen. Now some of you might, a lot of this code I can compact down into one line. And I can use dictionary comprehension. This is called dictionary comprehension here, just like list comprehension. And it really just takes these lines. It's got a for loop. It's got a for loop in there, and it says where we get the key and the value from, and puts them in the dictionary, and then stores that into a variable. I'll just create a new one. So I'll copy that. Let's create an empty cell here. And there's my dictionary that just got created all in one line. So that's pretty quick. Right, now we've been looking at tags, we've been looking at the string and text values inside the tags. But what about the attributes? So an attribute, let's have a look at here. So here's a tag name, and anything inside the tag with an equal sign, that's an attribute. So rdf::about is an attribute name, and there's the value of that attribute. So let's see how Beautiful Soup can get the attributes, and it uses this the square bracket notation. So this is where you use square brackets in Beautiful Soup. So let's see. So soup.channel rtf::about, soup.channel. Let's find what channel is. There's channel rdf::about, and there it is. So we should expect that URL. And that's what we got. So for tags, the namespace qualifier is optional. So remember before we could look up LIs, or we could look up RDF::LI. I think I was doing that with target currency, CB::target currency, or just target currency. So all these three ways of referencing the tag give us the same results. Attributes. Oh yeah, and we've already said that the attributes here needed to have the namespace, so you can't do just the about on that. Well, let's try it and see what happens. And it gives a key error, so I needed to put the namespace in there to be able to reference it. Okay, so Leo's question, can we go straight to JPY? And we can use the find function, we give it the tag name, and then we say we want attribute value string to equal JPY. So once we've found that target currency, that's going to be a tag, and we want to find the parent of that, which is the exchange rate, and then we want to find within that exchange rate, we want to find the value tag, and then from that value tag we want to find the text that that it has. So we're able to put all of that into one single command, and it comes up with 82.18. Now you can pass in any keyword arguments here into the find command. They can be passed. They can be strings, a list of strings, regular expressions, functions, or true. So let's have a look at each of those things that we can do with keyword arguments in a using the find function. If you want to read about how to use find function as well as using the online documentation, it comes with soup.find. It comes with in the help. So Python has the help function, and you can see that we can put in attributes, we can put in keyword arguments, matching the given criteria. It doesn't tell us much about how we specify that. So let's have a look at help for soup.findAll, and that's giving us a bit more information. The value of a key value pair in the attributes map can be a string, a list of strings, a regular expression object, or a callable, that's what I said, function, that takes a string and returns whether or not the string matches the same custom definition of matches. Okay. So our next exercise is going to be using the ACCC site to find petrol buying advice in Brisbane. So let's have a quick look at the site. I'll open that URL, and this is the Australian Competition and Consumer Commission, and they've got petrol prices in different places, so we can click on here. If you look at the URL at the bottom of the screen, it goes to hash petrol prices in Brisbane. I'll take that. It'll show us that petrol prices were this. They shot up to $1.85. They've gone down to $1.67, but they're already on their way up again. So prices are increasing. If motorists shop around, they may be able to find some increased prices, some prices not yet increased. Okay, and then there's a table underneath that which goes through some of the old previous cycles that we've had. When the highest price in the cycle was, when the lowest price, how long the cycle is. So we're going to try to get this data. So this is HTML data, so it's a bit different to XML data. Let's use Beautiful Soup to get this data. So here's the difference here in our features. We now say HTML parser rather than XML. And there were a couple of other options that you could have used there. Okay. So our first thing we're going to do is find all the H2 tags. And there they are. You can see they've got IDs like petrol price cycles in capital cities, petrol prices in Sydney, Melbourne, Brisbane. So they're the H2 tags. There's also these ones lower on that we're not really interested in. So we can filter using find all just by putting in a class name. So we only want the ones that are these table of contents headers. We don't these ones here. We don't want all these other ones which are class block title. So that's enabled us to filter and just get the H2s that have got that are used in the table of contents. Alright, now the most reliable way to search for stuff is on ID, because the ID should be unique in a HTML page. So we want to find the Brisbane anchor. So let's have a look at, we want to find this, how we get this H2 here. So let's have a look. I'm going to press F12. And that lets me inspect a particular thing. So we'll inspect this H2, and if we look at the H2 here, it's a bit small, sorry, but if you do this on your own computer, you should see, you'll see that here's the anchor here. It's got a name, petrol prices in Brisbane, and it's got an ID, petrol prices in Brisbane. So that's the one that we can use that ID to go straight to the anchor. But you can see the anchor is actually a sub tag to the H2 tag, which closes down here. Right, so we're going to find anything that's got an ID equals petrol prices in Brisbane, which should be one thing. So we can either type it like this, or we can say attributes equals and put in a dictionary. So normally it's easier just to put the attribute name and the code, but sometimes you're going to have an attribute name that won't work in this scenario. For example, data-foo won't work because it's got a minus sign in it, and you can't have minus signs in attribute in keyword argument names in any Python function. So it can't be used here. And similarly, name you can't use because, as we saw before, the find function already uses name for something else. Okay, so let's get our anchor Brisbane, and here it is, exactly as it came from the web page. There's no text in it, but it's got an ID and a name, and it's enclosed in the H2. So we need to find the parent, which is the H2. So we can take our Brisbane anchor and go up to the parent, and we get our H2. I've put it here in a variable called UL, which you'll see why in a minute. And then we're going to jump through until we find an actual UL. So we can do that by using next sibling, which is a beautiful soup way of stepping through tags that are of equal level. So it doesn't look at descendants, which is what we were looking at before. It's looking at siblings, so brothers and sisters, which until it finds one which has actually got the name UL. So it'll keep looping through until it finds ul.name equals UL, in which case it'll stop and say what it found. So let's run this code, and it prints out some logging here so that you can see how it found it. So the first sibling it found was nothing. It was just an empty string with just a carriage return in it. So this is a problem with siblings, is that they include empty text between tags. Then the next sibling it found was a paragraph tag, which is of type tag, and inside that it had the text buying tip. Then it found another bit of empty text, and then it found a UL of type tag, and it had this text in it. So that's what we were after. UL now includes a tag, has a tag called of type UL. I mean, we could easily have just said, we couldn't have just said .ul there, because it would have found it would only have found a sub tag, but we want a tag that's at the same level as the H2. So that's why I had to use next sibling. Alright, and then we're able to print out the recommendation. Prices are increasing. If motorists shop around, they may find some retailers that have not yet increased prices. So that's how we're able to programmatically interrogate that website so that we can get some information from it. Okay, now I've got a question here. Is it necessary to write print soup exchange rate or that, find the first, or can we retrieve text using this code? Yeah, well, the bit that's retrieving the text is soup.find exchange rate. Although you need to say, yeah, and you can print that out. You need another closing brackets there. I like to use format strings. So this code that I've put in this Google Collab notebook, I've also put it in as a Python script, so which is slightly different to interactive Python. And so that's why I do the full print statements, because these ones, you're really actually, both of them have got the print statements, but you're asking, do we need to say all this descriptive stuff beforehand? And I'm putting it there because when you run the Python script, it's got no context if it just shows an answer. In the Google Collab, you got a bit of context because the printed result shows just after the cell that it got run from. But when you're running a Python script, it goes right from the start of the script to the end of the script and runs all the code, and you just get a list of printouts. So by putting that extra bit at the beginning, you can see where you are, where that print statement came from, and what it's telling you. So yes, you don't need to do it, but it's handy when you're running it as a Python script. If you want to see those Python scripts, they're all in our GitHub site, and there's a link at the beginning of this Google Collab for the GitHub site, which repository, which is called Session Summaries. And the online folder there has got all these online Python scripts. So just look up the one, Meetup 133. Okay, so we found the first UL. Now that's apparently quite a common requirement. So the Beautiful Soup gives us this function here, find next sibling, and you can just put in the tag name there and it'll find the one that's got that tag name. So let's try running that, and sure enough, there's the results. So that's a bit easier than what we did up here. You'll notice I'm also using these format strings, these F strings. They're really useful, and you only get good at using them if you use them all the time. So try to use them as much as you can. So they've in a format string, you can put these curly braces in here, and every time there's a curly brace pair, it'll evaluate what's inside it rather than just print it literally. Anything to the left of the colon is the value that gets calculated. Anything to the right of the colon is the format you want to use for displaying it. So in this case, I want to display it 5 characters wide. This one 15 characters wide. All right, find when the next low price is going to be. Okay, so let's have a look at our petrol prices. We're going to find, we have to find this table here, and we need to find the low price of the cycle, and we find how many days in the cycle and add that number of days to that date, and that will tell us when the next low price is going to be. Okay, so think about how you might do that. Obviously what we want to do is let's have a look. We want to find that date, and that date here is in this table, and that table is on the same level as that unordered list. There there's our unordered list. So we've already got the unordered list. So we're looking for the next sibling, which is a table. And then we want to go find all the rows in that table, find the last row, and get the data out of that. All right. So I think I'll just go straight to the solution on that. I've done the pseudocode, really, how we're going to do it. So we're going to, in this case, assuming that we don't have the UL, we're going to find the anchor, the parent, which is the H2, and then find the next sibling to the H2, which is a table. Or we could have used find next sibling. In this case, it was fairly safe to just do find next. Then we're going to get all the TRs, find all within that table, and we've got table.tbody. We didn't really need the tbody. So that finds the first tbody and then all the TRs in that tbody. I guess the tbody helps us because it gets rid of the T head. But in this case, we're going for the last row anyway, so it doesn't really matter. Now in Python, to get the last item in an index, in a list, we use -1 index, which is a really useful feature in Python. That'll give us the last one, rather than having to calculate the length of the list and then subtract 1 from that to find out get the last item. And we're going to find all the TDs in that row, in that TR, and we'll store them in another list. And we know that the first TD stores a date, which we're going to parse using the date-time library. So there's a fair bit here that I'm assuming you're going to have to work out. We haven't gone through it previously in tonight's session. So it's probably a good thing that we're just jumping straight to the solution, because we wouldn't have been able to work this out just with the knowledge that we had. And so we've got the first cell, and cell index 4 will give us the days in the cycle, and then the next date low is going to be the previous low plus that number of days, and let's print out the result. So it's saying the next low is going to be on the 2nd of January 2022. So obviously the ACCC aren't keeping their tables up to date because we're well past that. And even their graph shows that we're well past it, because they've got 2nd of February here is another low, and even they're showing the 2nd of January. So we predicted this one based on that last data, which was reasonably accurate, and then we've got another one, but they haven't given us that data. All right, so remember when we looked up the help for find, it said we could use regular expressions. So here's an example of how to use a regular expression. Task 5, find the date of the last low price for every city with a name ending in E. So we won't probably go into regular expressions too much tonight, but I find this website pretty useful, regex101.com, for practicing regular expressions, because they're pretty hard to get your head around. So here's an example of a regular expression. We use an R string. Remember, we've used F string, so put an R out the front of quotation marks and you create a raw string, and the raw string lets you use backslashes without having to escape them all the time. And that's handy because in regular expressions, backslash has a special meaning, so there's usually backslashes in regular expressions. So we want to find anything that goes petrol prices in, we're looking for an ID, and then a whole bunch of word characters. So backslash W means a word character, and the asterisk means as many as we want, 0 or more of these word characters, followed by an E, and then followed by the end of the string. So that will give us all the cities with names ending in E, and we can then loop through those anchors and find, what are we doing? We're looking for the last space in that string. So looking at from the right hand end, and then we're taking everything from that space onwards, which will be the just the city name, and we're going to look at the table and find the last low price in each of the cities. Okay, so that's all done. RE is not and so I've got to remember to run this cell here to import RE first, and there we go. The last low price in Melbourne is 11th of November, 12th of November and 29th of December. So it looks like Adelaide's been kept up to date, but the other cities not so much. Okay, task 6. From the RBA website, find the full name of the currencies IDR and INR. Alright, so let's have a look at this website and see if we can work out from it how we're going to find that information. So this is a web page, so we're going to be using HTML web scraping. We've got a list of all, here is the full names of all the countries that have got the exchange rates, and so these are the same countries that are in the RSS feed, but in the RSS feed we've just got the codes, and here we've just got the names. So we want to somehow match the full country names with the codes. And how are we going to do that? So let's have a look. I'll press F12 to inspect this code, and I'll click on this button here which says I want to inspect a particular thing. So let's inspect Hong Kong dollar, and I look at that row and I can see Hong Kong dollar, and very fortunately they're using the currency code as the ID for that row. So that means if I look up the ID for that, the row with the ID for the currency code, I can then find pretty easily what the name of the country is that uses it. Let's have a look at the solution. We're going to open the URL, which was that HTML page. We're going to tell it that it's a HTML page, not an XML page. And we're going to find all the rows that have an ID of either IDR or INR. Okay, so remember when we looked up the find command, it said you can put a list of strings. So this is how we're using a list of strings to find it. So both of those rows will be returned by the find all. Then we'll loop through those two in our list, and we'll find the header cell, and the string in the TH cell will be the currency, and the ID will be the currency code. Okay, and they've obviously changed their website since I wrote this, so let's go and have a look at the website and see what we've got. So the TH is what we're looking for, and we're looking for IDR and INR. So these look alright. Yep. So why didn't it find it? And the reason it didn't find it is because it's looking at the wrong URL. So once again, I forgot to run this cell to set the URL to the new value. And then I'll run this cell to use that URL. And now it's found it. The code IDR is the Indonesian rupiah, and the INR is the Indian rupee. So these numbers in the square brackets are useful to tell whether you've run a cell or not. So now I can see that 40 has been run, but task 7 hasn't been run, but that doesn't matter, it's only comments. so it's not going to do anything. Alright, so task 7. From the RBA page showing rates over the last 3 days, find currencies where the rates have both increased and decreased over that time period. So you can see we've got 3 days, 4th, 7th and 8th of February, and this one, it's gone down and then up. This one's gone down and then up, down and then up. Oh, so we're going to get quite a few today. So we're going to call them procrastinating rates because they don't know whether to go up or down. So what we're going to do, we're going to define a function here called procrastinate, which is going to find any procrastinating rate. We're going to pass in the tag, which is going to be a TR, which is a row in the table. We're going to look at the 0, 1 and 2 index TDs, and we're going to see if either R1 is less than R2, which is greater than R3, or R1 is greater than R2, which is less than R3. So that means the rates have gone up and then down, or this one they've gone down and then up. And we used OR in there. So this will give us a true or false response. Now we can find the T body for our table. So we're finding that by looking at the H2 called latest exchange rates and the next symboling, which is a table, and getting the body from that. And then we're going to look at all the TRs that are in that body, and we pass in a function, and every tag that's in that T body will get passed in to this function, and that function will return false if it's not even a TR, and if it is a TR, it'll look at the cells in the TR and return true or false. So it's pretty powerful stuff that we can do here. Once we've defined that function, we just call find all with procrastinate, and then we've got a list of TRs that are the rates going up and down, and we just print them out to confirm that they are in fact. So there's down then up, down then up, down then up, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's just about all of them. I think there's 20 in total. All right, now the last thing, we're just really going through the help file for find all at the moment. The last one was we could just pass in true for a particular attribute. So let's find all the tags which have an ID attribute. So that's pretty easy. For the same site, RBA HTML, find all where ID equals true, and then we'll just print out those tags that have got an ID and what the ID is. Yep. So that's the name of the tag as a div, and that's the ID, page exchange rates. A top div global header. Okay. And there's all our TRs, which have got our IDs for our currency codes. Now what you'll find interesting here is that there's no H2s in this list. And you might think, well, that's because none of the H2s have an ID. So let's have a look at the HTML code, and we'll find an H2 tag. Here it is. So there's H2. It's got an ID of graphs. And I think there's some more that I haven't found. H2 ID latest exchange rates. So those H2s do actually have IDs, but when we looked for them in our using Beautiful Soup, we didn't find them. And the reason for that is that when we're loading the HTML page, we get it exactly as it is when it's immediately created. But what can happen is on these pages is that they can then run some JavaScript, and the JavaScript can actually add extra code in. So the JavaScript has put these IDs on these H2 tags that didn't exist prior when the page was first loaded. And we can see that. I'll just close this developer tools, and I'll type Control U, which will open up the code. Now this gives us the code as it was originally, and we'll look at this is before the JavaScript got run. We'll look for an H2 tag in there. And there it is, H2, latest exchange rates, and as you can see there's no ID on the H2. So this is before any JavaScript has been run, which has been creating a few IDs for us. Okay, so that's the end of tonight's session. I hope you enjoyed it. If you like it, please press like on the video and subscribe to the channel if you want to be updated when there's more of these. Next week, the next couple of weeks, we'll have Arun. We'll be teaching machine learning, so be sure to come along to that. And then on the first week of March, I'll be running a absolute beginner session. Hope you enjoyed it, and I will see you later.